I am Anmelia Joni and my topic is about space-based solar power and is guided by Anuja George. These are the contents included in my topic: introduction, how space-based solar power work, block diagram of space-based solar power, how is space-based solar power different from traditional solar power, comparative study, how is it possible, current space-based solar power projects and progress, advantages and disadvantages of space-based solar power, real-world examples, solution for challenges, recent technological advancements, problems with present source of power, applications, space-based desired solar power applications for desired irrigation, conclusion and references. Introduction. Space-based solar power is a method of generating electricity by capturing sunlight in space and transmitting it to Earth using a wireless power transmission system. This technology involves placing solar panels in orbit around the Earth where they can capture more sunlight without any atmospheric interference. The collected power is then transmitted to the Earth by a microwave or laser transmission system that can convert energy into electricity. Block diagram. Sunlight hits solar energy in space, which converts light into electricity. The electricity is converted from DC to AC using microwave earth circuits. AC circuit is transmitted into Earth using microwave beam. Then antenna on Earth receives microwave beam and convert it back to DC electricity. The DC electricity is used to power home and appliances. How space-based solar power works. This sequence outlines process of generating electricity from sunlight. Solar panels are designed to capture sunlight using photovoltaic cells. Solar panels absorb sunlight and this energy is converted into usable form. Photovoltaic cells within solar panel play a crucial role in converting absorbed solar energy into electrical energy. The generated DC electricity is then transmitted through an inverter. The inverter transforms DC electricity into AC, it aligning it with type commonly used in residential and commercial use. Converted electricity is now suitable for powering various electrical devices which includes lighting, appliances and other everyday electronics. How is space-based solar power different from traditional solar power? The primary difference between the space-based solar power and conventional type solar power lies in the placement of the solar panels. In traditional solar panels are placed on rooftop, in field or on other surfaces of Earth. On the other hand, in space-based solar power, it positioning solar panels in Earth orbit, enabling them to capture sunlight without atmospheric disruption and interference. The next difference is space-based solar power offers continuous 24/7 energy generation potential. But in traditional solar power, which is dependent only on daylight hours and weather conditions. Comparative study. The comparative study of space-based solar power system and earth-based solar power system. The efficiency of space-based solar power system is 8 to 10 times more as compared to earth-based solar power system. There is no effect in space-based solar power of effect of external condition, but effect of external condition is high in earth-based solar power system. In space-based solar power system, effect of its movements there is no effect, but in earth-based solar power system, its movements unable to capture energy during night. In space-based solar power system, there is no energy loss, but in earth-based solar power system, there is distorted energy waves. How is it possible? Space-based solar power essentially consists of three elements. The first is the collection, second transmission, and third reception. Collection. The basic concepts related to energy collection are utilizing solar thermal or photovoltaics, that is solar panels. One concept of solar thermal essentially captures solar energy by using mirrors to concentrate light and heat up a liquid. This in turn spins a turbine to generate electricity. This concept allows for a potential weight advantage over solar panels as it could reduce overall mass percentage. Transmission. There are two types of transmission: microwave power transmission and laser power transmission. Microwave power transmission. Shorter microwave wavelength enhance directional power transmission, enabling longer distance power beaming. A retina may be used to convert the microwave energy into electricity. A study conducted by NASA for solar power satellite necessitated a 1 km transmitting antenna and a 10 km receiving antenna for a 2.45 GHz microwave beam. Experiments in the tens of kilowatts had been performed. Under experimental conditions, the conversion of efficiency measured around 85%. Next type is the laser power beaming. Laser power beaming transfers allow transfer of power. The laser power beaming efficiency ranges from 10% to 20%. Power can be transmitted by converting electricity into a laser beam that is then pointed at a photovoltaic cell. Third is the reception. Earth-based reception receiver. Earth-based retina comprises numerous short dipole antennae interconnected by diodes. Microwave broadcast from the satellite would be received in the dipoles with about 85% efficiency. Retina would likely be several kilometers across. Retina. Special type of antenna used to convert microwave energy into direct current electricity. Simple retina element consists of dipole antenna with RF diode connected across dipole elements. The diode rectifies AC current induced in antenna by microwaves to produce DC power, which powers load connected across the diodes. Current space-based solar power projects and progress. The current space-based solar power and project and progress includes: first is the China Aerospace Science and Technology Corporation plans to launch small to medium solar satellite in the stratosphere that can harness energy in between the year 2021 and 2025. Second, in United States, Space Solar Power Initiative, which aims to develop innovation enabling space-based solar power to generate electricity at competitive cost with current sources. Third, in Japan, researchers successfully transmitted 1.8 kilowatt of electric power as microwave to a receiver of 55 meters away, marking significant technological steps towards realizing space-based solar power. Fourth, in Japan also made space-based solar power system part of its future space exploration mission. Fifth, Solar Space Inc. is a private company working on space-based solar power projects including the SPS-200 system. The SPS-200 system aims to generate and transmit electricity to Earth using a fleet of satellites. Power Sixth is the PowerSat International, which is developing the PowerSat system, a based solar power project that uses a single satellite to generate and transmit electricity to Earth, currently in development of ground. Eighth is the European Space Agency. European Space Agency is developing a new type of shielding material that can protect space-based solar power system from space debris. China also plans to generate 1 MHz of energy from space-based solar panels by year 2013 and to be operating a commercially viable solar power station by upcoming year 2015. There are many advantages and disadvantages. The advantages of space-based solar power are it is unaffected by weather. Second, reduced environmental impact. Third, reduced land use. Fourth, reduced transmission losses. Fifth, continuous power generation. The disadvantages included are high initial cost, orbital placement and station keeping, space debris and collision risk, vulnerability to space weather, and risk of failure. Solutions for challenges. The first is cost. To reduce cost, the one way is to develop more efficient solar panels and power transmission system. Another way is to reduce the size and weight of space-based solar power system. Second is the safety. Space-based solar power system can be prioritized safety and reliability through redundancy and sensors to maintain the operation in case of malfunctions. Third is the public acceptance. This can be done by educating the public about the benefits of space-based solar power and by addressing any concerns that people may have. The recent technological advancements. First, more efficient solar panels. This makes space-based solar power system more feasible as they can generate more power from a smaller solar array. Second is the lightweight power transmission system. Microwave and laser power transmission systems are being developed that are more efficient and lightweight. Advances in artificial intelligence and machine learning. The advancements in artificial intelligence and machine learning can be used to improve the safety and reliability of space-based solar power system. Fourth is the PowerSat International. The PowerSat International is developing a new type of ground-based receiver that is more efficient and more affordable than traditional ground-based receivers. Real-world examples of space-based solar power. The first is the SPS Alpha project. The SPS Alpha project is a joint effort by NASA and ESA. The SPS Alpha project aims to create a 10-volt SPS system for supplying power to remote or disaster affected regions. The second is the PowerSat project. The PowerSat project is a private initiative to develop a 10 MHz space-based solar power system. The PowerSat system is designed to be devolved in geosynchronous orbit and could be used to provide power to larger cities or industrial complexes. The SPS 200 project. The project is a private initiative to develop a 200 kilowatt space-based solar power system. The SPS 200 system is designed to be developed in low Earth SPS 200 orbit and could use to power remote communities or provide backup to the grid. The SPS 200 precision optimizes polishes process PAs, SPS and freeform surfaces within a working range of about 5 to 200 mm, but also a wide spectrum of other optical surfaces such as cylinders, toroids. Problems with present source of power. Some specific problems with the present source of power that space-based solar power can potentially address are fossil fuel depletion. Space-based solar power can provide a clean and suitable alternative to fossil fuel. Climate change. Space-based solar power does not produce greenhouse gases, so it can help to mitigate climate changes. Energy reliability. Space-based solar power can provide a reliable source of energy as the sun always shines in space. This could be important for countries that are vulnerable to power outages. Reduced transmission losses. Traditional long-distance electrical transmission lines can suffer from significant energy losses during transmission. Space-based solar power can transmit the power wirelessly with minimal losses, improving overall energy efficiency. Energy access in remote areas. Many remote and off-grid areas lack access to reliable electricity due to the challenges of building traditional power infrastructures. Space-based solar power can transmit energy to this remote location, providing access to clean and consistent power. Applications. There are many applications of space-based solar power, shaping the future with photovoltaics, providing energy to remote areas, powering space infrastructure, reducing greenhouse gas emission, powering houses and businesses, creating jobs, and generating electricity. Space-based desert solar power applications for desert irrigation. Space-based desert solar power is a proposed technology that would collect solar energy in space and transmit it to Earth using microwaves or laser. Space-based solar power could be used to power desalination plants to produce fresh water for desert irrigation or to power pumps to lift water from underground aquifers or to transport water from distant sources. Space-based solar power has the potential to pot- revel- revolutionize desert irrigation and make it possible to green desert and create new agricultural opportunities. It could also provide a sustainable source of energy for the desert communities. Advantages of space-based solar power for desert irrigation. Space-based solar power can collect solar energy 24 by 7 regardless of weather conditions. This is important for desert irrigation, which often takes place in remote areas with limited access to other energy sources. Space-based solar power can generate a large amount of electricity from a small area. This is important for desert irrigation where land is often scarce. Space-based solar power can transmit electricity to long distance without losses. This is important for desert irrigation which often takes place in remote areas. In essence, space-based solar power has the potential to revolutionize desert agriculture, promote environmental sustainability, and enhance the quality of life in arid areas, which offering a model for sustainable energy solution worldwide. Conclusion. In future, globe will need more energy. Solar energy available in space is literally billions of times greater than we use today. With continued research and development, space-based solar power could play a major role in our energy future. Overall, space-based solar power is a promising technology with the potential to make a significant contribution to our energy needs. However, there are still a number of challenges that need to be overcome before it can become a reality. Despite space-based solar power is not within its challenges, overcoming the technical, logistic, and economic hardness associated with launching and maintaining solar power stations in space, as well as safely transmitting energy to Earth, is no smaller feat. It required concerted effort in innovation, infrastructure development, and international collaboration. Yet, as we address these challenges, space-based solar power remains a beacon of hope, offering a path towards a cleaner, more abundant, and efficiently reasonable energy future that can benefit of all humanities. These are the references I use for this presentation. Thank you.